Hello everyone. So hope you all are good. You all are enjoying your life. So without wasting time, let's start today's topic, that is structure of atom. Now, today we will discuss these topics. First is what is atom. Okay. Second one is composition of atom. Third, atomic number. Fourth, atomic mass. Fifth, properties of particles in an atom. And at the last, we will discuss arrangement of electrons in an atom. Means in an atom, how the electrons are arranged. Okay. Next. So now today's first topic is the what is atom. Now what is atom? So atom, it is the smallest particle of an element. Okay, so here is a question, what is an element? So element, like you can consider say hydrogen, okay, you can consider say helium, oxygen, carbon, etc., iron. Okay, so every element, it is made up of very small particles. Those small particles are called atoms, and those small particles which may or may not have an independent existence. Okay, so may have an independent existence, like you can say helium, argon. Okay, so these atoms has independent existence, but others, some examples say like you can say carbon, hydrogen. Okay, so these types of elements, these atoms, they cannot exist independent. Okay, so they always exist in some either similar type of atom or different type of atoms, like in the bonding. Say example, suppose you can consider a carbon. Okay, so if it makes a bond to the four hydrogen atoms, okay, so then it exists in the form of methane gas. Okay, so this is the formula of methane. Okay, so here carbon do not exist independently, same way hydrogen here. So hydrogen also do not exist independent. Okay, so atom, it is the smallest particle of atom, and which may or may not have independent existence. Okay, but these atoms always takes place in the chemical reaction. Okay, example you can say carbon plus oxygen, arrow CO2. Okay, so when the carbon is heated in the presence of oxygen gas, so then carbon dioxide gas is formed. Okay, so here this is the chemical reaction. So carbon, it is an atom, oxygen, it is a molecule which is made up of two oxygen atoms. Okay, so when these two reacts with each other in the presence of heat, then carbon dioxide gas is formed. Okay, so now what is atom? It is the smallest particle of an atom which may or may not have independent existence, but they takes place in the chemical reaction. Okay, so this is called atom. Now point, the size of atom is extremely small. Okay, so it is very small in size, which is much smaller than our imagination. Means we cannot imagine the size of atom. Next, so all atoms of the same element, like you can say, suppose you have iron piece, say. Okay, suppose you have an iron piece. So all the atoms of this iron piece are same. Okay, so they are all atoms are identical. So here I have taken an example. Okay, so all atoms of the same element. So here I have taken say iron. You can also consider say oxygen. Okay, or any other element. Okay. So in every element, the atoms of every element, so they are identical in nature, but different elements have a different types of atoms. Okay, so take an example. Suppose take two different elements. So first is iron and second one is say methane. Okay, or so not methane, sorry, you can consider say it's carbon. Okay, so iron, it is a different element, carbon, it is a different element. So atoms of iron element and the atoms of carbon element, so they are different. Atoms of iron element and atoms of carbon, so they are different each other. Okay, So that means if the same element is there, all atoms are same, identical. But if different elements are there, then atoms of different elements have a different types. Okay, so every element has different type of atoms. Clear? Next, composition of atom means atom is made of what type of particles. Okay, or you can say what type of particles are present in an atom. Okay, so this is the structure of atom, you can say. So the central part, this is called nucleus. Okay, and inside the nucleus there are two types of particles are there, protons and neutrons. But there is third type of particles are also present in the atom, but not present inside the nucleus of an atom. So those are called electrons. Electrons are present outside the nucleus but present inside the atom. Okay, so I repeat, protons and neutrons, they are present inside the nucleus of an atom, but electrons are present outside the nucleus but they are present inside the atom. Okay, so that means there are total 3 types of particles are present inside the atom. First one is first protons, second neutron, third is electrons. Okay, so these are the 3 types of particles which are present inside the atom. Proton and neutrons are present inside the nucleus, but electrons, they are present around the nucleus, and they revolve around the nucleus. Okay, they revolve around the nucleus in energy levels. Okay, so this is the first energy level. Okay, this is the second energy level, means say this one. Okay, this is the first energy level and this is the second energy level. Clear? And number of electrons are vary according to the type of atom. If atomic number increase, then number of electrons and protons, they also increase, number of neutrons also. Okay, so shells, these energy levels, means you can say these energy level, if there is a third, if there is a fourth. Okay, so number of shells increase according to the type of atom. Okay, if a number of electrons increase, the number of shells also increase. That means the number of energy level also increase. Next, now our next topic is the atomic number. Okay, so atomic number means number of atom. Okay, means atomic number. So every atom has a different number. So atomic number, it is represented by capital Z. Atomic number, it is represented by capital Z, and it is equal to what? So it is equal to the number of protons in the nucleus of an atom. Means suppose you have suppose there is an atom, and inside the atom, say here is an example, say oxygen atom. Okay, so atomic number of oxygen atom is 8. It means what? It means number of protons inside the nucleus of oxygen atom is also 8. Okay, so number of protons decide the number of protons decide the atomic number. If a number of protons are 8, then atomic number is also 8. Okay, if a number of protons are 9, then atomic number is also 9. Okay, so take another example. Say in the case of a hydrogen, number of protons is 1. Okay, so atomic number is also 1. In the case of say helium, number of protons are 2, so atomic number is also 2. Okay, say lithium, atomic number is 2 because in the case of lithium, number of protons are 3, so that is why atomic number is also 3. Okay, take another example. Say carbon, number of protons inside the nucleus of carbon atom, say it is 6. Okay, and that is why atomic number is also 6. Okay, so here is also an example, that is atomic number, that is oxygen. In the case of oxygen, atomic number is 8. Why? Because the number of protons inside the nucleus of atom is 8. Okay, so this red colored, they are shown, that is protons. Okay, so you can count. So 8 protons are there inside the nucleus of atom. So number of protons decide the atomic number. And for a neutral atom, number of protons, it is also equal to number of electrons. Okay, it means what? It means if atomic number is 8, then how many number of protons are there? 8. How many number of electrons are there? There are also 8. You can count 1, 2, 3, 4, 5, 6, 7 and 8. Okay, but for a neutral atom. But if there is a cation or anion, then number of electrons may vary. Okay, but for a neutral atom, number of protons and number of electrons are same. Okay, but number of neutrons, they vary from one atom to another atom, and sometimes the atomic number is different, number of neutrons are also different. Okay, but who decides the atomic number? The correct answer is the number of protons. Okay, but for a neutral atom, number of protons and number of electrons are same. Okay, next, atomic mass. Atomic mass means what? Mass of an atom. It is called atomic mass. Atomic mass, it is represented by capital A. Okay, but we already learned in the case of atomic number was represented by Z, and now here it is atomic mass, it is represented by capital A. Atomic mass means what? Mass of atom. So we know that inside the atom, how many types of particles are there? We know that there are 3 types of particles are present. Okay, so first we know that the protons are there. Okay, then neutrons and electrons are there. So atomic mass means mass of atom. That means how many number of protons are there, how many number of neutrons are there, and how many number of electrons are there. Okay, then we can add, and then we will get the atomic mass. So mass of one proton particle, it is 1 AMU. Okay, AMU means atomic mass unit. Okay, so mass of proton is 1 AMU. Okay, at AMU means atomic mass unit. And the mass of neutron, it is also equal to mass of a proton. That means it is also 1 AMU. But mass of electron, it is very smaller. It is very small, smaller than as compared to the mass of proton and a neutron. So that is why we can generally neglect the mass of electrons as compared to the mass of neutron. So it is equal to, generally approximately it is equal to, if one proton, it is approximately equal to 1836 number of electrons. Mass of one proton, it is equal to 1836 mass of electrons. Okay, so that is why the mass of electron is neglected to count the mass of atomic mass. Okay, so that is why atomic mass, it is equal to the sum of number of protons and number of neutrons, because mass of electron is very less as compared to the mass of proton and mass of neutron. Okay, so atomic mass A, it is equal to what? Number of proton plus number of neutron. Okay, so here is an example. Say sodium. Now atomic number Z. Yes, atomic number of sodium is 11. So can you guess how many number of protons are there? Yes, we know the number of protons are also 11, because number of protons are 11, that means the atomic number is also 11. Okay, so you can say if atomic number is 11, number of protons are also 11. Clear? Now in the case of a sodium, 11 protons are there, but how many number of neutrons are there? 12. Okay, so in the case of a sodium, number of protons are 11 and number of neutrons are 12. So what is atomic mass? We know that number of protons plus number of neutrons. So number of protons are 11 and number of neutrons are 12. So what is atomic mass? That is 23 unit, U. Okay, 23 U. U represents the atomic mass unit. Okay, initially it was AMU, but now it is replaced with a simple U. Okay, so mass number means atomic mass. It is also called, that is mass number, that is 23. Okay, so in the case of sodium, mass number is 23, and atomic number is, we know that there is 11. So number of neutrons are 12. Okay, but in the case of a neutral sodium atom, we know that the number of protons are 11, number of electrons are also 11. Okay, in the case of a neutral sodium atom, we know that how many number of protons are there? 11. Okay, so charges on the 11 protons, that is plus 11, and charges on the 11 electrons, that is minus 11. So that is why on a neutral atom, 0 charge is there. But a neutron do not have any charge. Okay, next, some properties of particles in an atom. Okay, so actually I already explained to you in the previous slides. Now we know that in an atom there are 3 types of particles are there. The first is proton, second is neutron, third one is electron. Now the charge. Proton carry positive charge. But the neutron do not have any charge. That is why it is neutral in nature. Okay, so it has zero charge. That means no charge, zero charge. Okay, next electron. Electron carries negative charge. Okay, so that is why in the case of a neutral atom, number of protons or number of electrons are equal to each other. So that means a positive charge is equal to negative charge, so they cancel to each other, and atom as a whole, it is a neutral in nature. Okay, so that is what the charge. Now next is mass. Proton has 1 AMU mass. AMU means atomic mass unit. AMU, that is atomic mass unit. Now it is replaced with the simply U. Okay, so AMU simply it is now replaced with written as U. Same as the neutron, it is also 1 AMU. That means mass of proton and mass of neutron, it is the same, that is 1 AMU. But mass of electron, it is very, very small. Okay, so it is the 1 by 1840 AMU. Okay, so it is very, very small. Now, where these particles are present? Protons, these are present inside the nucleus of an atom. Neutron also, they are also present inside the nucleus of atom. But electrons, they are present inside the shells or orbits. Okay, so these shells or orbits, they are also called energy levels. Okay, next one more thing. Protons and neutrons, because they are present inside the nucleus, but electrons, they are present around the nucleus. Electron has very, very small mass as compared to proton and neutron. That means the mass of atom, it is generally concentrated at the center of an atom. You can say the mass of atom, it is concentrated inside the nucleus of atom. Okay, clear? Next, arrangement of electrons. How the electrons are arranged inside the atom. Okay, so sorry. Now we know that inside the atom at the center, this nucleus is there. Can you guess why this positive is written? Because inside the nucleus we know that proton and neutrons are there. Protons having positive charge, and neutron do not have any charge, so it has zero charge. So total charge on the nucleus is positive. So that is why a positive is here. So nucleus is present at the center of atom. Now next, energy levels. This is the first energy level, second energy level, third energy level, fourth energy level is there. Okay, so these are called shells. Okay, or orbits or energy level. So this is the first energy level at here. Then second energy level is there, then third energy level is there, then fourth energy level is there. Okay, and names. First energy level, it is represented by K. Second with L, third energy level with M, fourth energy level with N. Okay, and so on. Okay, and number of energy levels varies according to the number of electrons. If more number of electrons are there, then more number of shells are required to fulfill the electrons, because the electrons are present inside the shells. Clear? Now the maximum capacity of these shells or these energy levels to fill the electrons. Maximum capacity of a first energy level is 2. Maximum capacity of a second energy level to fill the electrons, that is 8. And maximum capacity of a third energy level, that is 18, and fourth 32. But suppose if there is an outermost shell, for an outermost shell accept the first energy level, for an outermost shell accept the first energy shell, maximum capacity of that shell, it is 8. Example, say suppose third energy level, it is the outermost energy level for a particular atom. Okay, we can take an example, say sodium, Na. Okay, we know that atomic number Z, it is equal to 11. So how many protons are there? 11. So how many electrons are there? There are also 11. Okay, so that means how many shells are required to fulfill the electrons? The 3, because in the first shell 2, and second energy level 8, and in the third shell only 1 electron will come. Okay, so 3 shells are required to fulfill the 11 electrons. But here third energy level, it is the outermost shell here. So maximum capacity of outermost shell, it is 8. But if another shells are also there, then maximum capacity varies according to this. Now formula to find the maximum capacity of maximum capacity of electrons to fulfill, that is 2n square. So n, it is the energy level. Okay, so n, it is equal to 1, 2, 3, 4 and so on. Okay, so n is the first energy level, 2 second energy level, 3 third energy level, 4 is the fourth energy level. Okay, so we can fill, so 2n square, suppose n is equal to 1. Okay, so 2 1 square, so it is equal to 1 square into 1, so that is equal to 2. So for the first energy level, maximum capacity is 2 C. Okay, and for the second energy level, that means n is equal to 2. So put the value, that is n is equal to 2 here. So if you fill, then you will get, that is 8. That means the maximum capacity of second energy level, that is 8. And similarly, you can easily find the maximum capacity of a third energy level, that is 18, by using this formula, that is 2n square. So if you fill n is equal to 3, then you will get the answer, and so on. So thank you very much.